Good day, stats enthusiasts. Welcome to this AI-assisted learning session. Today, we're diving into a statistical tool that's both practical and powerful, the Spearman's Row. Romance in the Ranks, exploring Spearman with JASP. In a partner senior high school of PNUNL in northern Luzon, a culturally responsive study explored whether active engagement in indigenous traditions correlates with academic performance among IP learners. Today, we'll use this context to learn how to apply and interpret Spearman's Row using JASP. By the end of this session, you will be able to understand the concept and appropriate use of Spearman's Row in analyzing the relationship between two variables. Analyze and interpret Spearman's Row results using statistical software such as JASP. Before we dive into the statistics, let's clarify our tool. For today's session, we'll be using JASP. It provides clear visual outputs and lets you easily run non-parametric tests like Spearman's Row with just a few clicks. Let's start by understanding what Spearman's rank correlation coefficient, or Spearman's Row, is. Spearman's rank correlation examines the relationship between two variables. Isn't that exactly what Pearson correlation does? That's right. The Spearman rank correlation is the non-parametric counterpart of the Pearson correlation. Spearman does not use the raw data, but the ranks of the data, making it ideal for ordinal data, data with outliers, or when the relationship is monotonic but not strictly linear. This makes Spearman's Row more flexible when Pearson's assumptions are not met. Now let's take a look at the formula behind Spearman's Row. It's based on the difference between the ranks of each paired observation and looks like this. This expresses the strength and direction of a monotonic relationship between two ranked variables. A value close to +1 means a strong positive correlation. As one rank increases, so does the other. A value close to -1 means a strong negative correlation. As one rank increases, the other decreases. A value around 0 suggests no monotonic relationship between the variables. Don't worry, we're not doing this by hand. Instead, we'll let JASP do the number crunching for us. What's important for us is not memorizing the formula, but understanding what the results mean. And that's what we'll focus on next. Now, let's apply Spearman's Row using a local example. Let's say we conducted a study in a local school with Indigenous peoples, IP students, and we wanted to find out, does being more involved in cultural activities relate to how well these students perform in school? To explore this, we surveyed 23 IP students and collected two sets of data for each student. Cultural engagement score, based on how actively they participate in cultural events. Academic performance score, based on their general academic performance in class. Why use Spearman's Row? Because we're not assuming a perfectly straight line relationship. We just want to see if there's a consistent trend. Step 1. State hypotheses. All right, before we jump into the actual test, the first thing we need to do is set up our hypotheses. So, what are they? The null hypothesis is like saying, there's no clear pattern between the two variables. One doesn't consistently go up or down when the other changes. On the other hand, the alternative hypothesis says, hey, there is a pattern, a monotonic relationship. Let's make it concrete with our example. Null hypothesis. There is no monotonic relationship between cultural engagement score and academic performance score. This means that a student's level of cultural engagement doesn't show any consistent connection with how well they do in school. Alternative hypothesis. There is a monotonic relationship between cultural engagement and academic performance. So, as students become more involved in cultural activities, their academic performance tends to either go up or down in a consistent pattern. Step 2. Check assumptions. Before we go ahead with the Spearman's rank correlation, we need to pause and ask, is this test the right fit for our data? To answer that, we check two important assumptions. First, our variables should be at least ordinal. That means the data should be something we can rank, like from low to high. In our case, we are working with cultural engagement score and academic performance score, both of which are ratio level data. According to the JASP Student Guide, version 0.19.3 on page 73, Spearman's Row and Kendall's Tau are described as being based on ranking data. While the guide does not explicitly state that JASP automatically ranks ratio-level data, it is understood that since Spearman and Kendall are rank-based methods, JASP internally performs the ranking of the data when these tests are selected, regardless of whether the data are ordinal, interval, or ratio in nature. So this assumption is met. Second, there should be a monotonic relationship between the two variables. This means that as one variable increases, the others should generally go up or go down. And to check this, we can plot the data on a scatter plot. If the dots show a steady upward or downward pattern, even if it curves, we're good. If that's what we see, then this assumption is also met. Step 3. Run the test in JASP. Here's how you can do it, step by step. 1. Open JASP and load your data file. Click the hamburger icon on the upper left corner, then click Open, and select your data set. It can be in Excel, CSV, or .sav format. Make sure your data set includes 2 columns. Before we go to the correlation analysis, we first need to check if our data meet the assumption of normality. This helps us decide whether to use Pearson's correlation or Spearman's rho. In JASP, we go to the Descriptives menu, select our variables, Cultural Engagement Score and Academic Performance Score, and enable both the median and the Shapiro-Wilk test. First, we compare the mean and median of each variable to get a quick idea of the data distribution. For Cultural Engagement Score, the mean is 72.26 and the median is 71.0. Since they are close, the distribution appears approximately normal. For Academic Performance Score, the mean is 70.65 and the median is 77.0. The gap suggests the data might be skewed. Next, we look at the Shapiro-Wilk test results. If the p-value is greater than 0.05, the data are considered normally distributed and we can use Pearson's correlation. If the p-value is less than 0.05, the data violates normality and we should use Spearman's rho. In our case, Cultural Engagement Score had a p-value of 0.332, so it meets the normality assumption. However, Academic Performance Score had a p-value of 0.004, which violates normality. Since one variable is not normally distributed, we used Spearman's rho for the correlation analysis. 2. Go to the correlation analysis. From the top menu, click on Regression, then choose Correlation. 3. Select your variables. In the analysis panel that appears, you will see a list of your variables on the left side. Move them to the variables box by clicking the arrow or dragging them over. 4. Choose the Spearman correlation. Under Correlation Coefficients, uncheck the box for Pearson. That's for linear relationships. Then check the box for Spearman. To enhance your output and make your analysis more informative, you may also check the following options. Display pairwise shows the correlation result for each pair of variables side by side. Report significance includes p-values to help determine if the correlation is statistically significant. Flag significant correlations adds an asterisk to highlight significant results. Sample size shows how many participants or data points were included. 5. Add a visual, optional. Under the Plots section, check the box for scatter plots. This helps you visually see the trend between the two variables, whether it's going up or down. Step 4. Review the results. After running the Spearman's test in JASP, you'll see your results in the output window, including a correlation table and, if selected, a scatter plot. Now let's walk through what these results mean and what to look for. 1. Sample size, n. In our case, n equals 23, which is a decent sample size for reliable results. 2. Spearman's rho. This is the main value we're looking at. It shows the strength and direction of the relationship, ranging from -1 to +1. Here's a quick guide. In our case, rho value equals 0.621, which means a strong positive relationship. As cultural engagement goes up, academic performance tends to go up too. 3. Degrees of freedom, df. For Spearman's correlation, degrees of freedom are calculated as df equals n minus 2. In our case, df equals 23 minus 2 equals 21. This is useful when reporting results in APA format or conducting follow-up analyses. 4. P-value. The p-value tells us if the result is statistically significant. Decision rule. If p is less than 0.05, the result is statistically significant. We reject the null hypothesis. But if p greater than or equal to 0.05, the result is not statistically significant. We fail to reject the null hypothesis. In our example, the p-value is 0.002, which is less than 0.05. Therefore, we conclude that the result is statistically significant. So we reject the null hypothesis and say there is a monotonic relationship between cultural engagement and academic performance. You may also notice asterisk next to the rho value in the JASP output to indicate significance. Since p equals 0.002, it's marked with 2 asterisks, meaning it's highly significant. 5. Scatterplot, optional. If you turned on the scatterplot, you'll see a graph of the two variables. A clear upward trend in the dots means a positive monotonic relationship. And in our case, that's exactly what we see, supporting the statistical results visually. Step 5. Conclusion and state final interpretation. We focused on 2 key results. Spearman's rho, to measure the strength and direction of the relationship, the p-value, to check if the result is statistically significant. This is our final interpretation. Spearman's rank order correlation was conducted to examine the relationship between students' cultural engagement and academic performance. Results showed that there was a significant and strong positive correlation between cultural engagement and academic performance. This indicates that as students' cultural engagement increases, Their academic performance also tends to increase. That's the real power of Spearman's. It helps us spot patterns in the real world, even when the relationship isn't perfectly straight or linear. It's especially useful when we're working with ranked or non-normal data, which is often the case in education and social research. Until next time, in another episode of Non-Parametric Test, dear stats enthusiast.